Today we are going to learn about similar figures. If two flat shapes are the same but one is larger or smaller than the other, they are said to be similar figures. An easy way to test similarity is to consider transformations that could make one into the other: enlarge or shrink, flip, or rotate. Notice anything about these two pictures of an Australian wombat? The pictures are of the same cute little animal, but the picture on the right is smaller in both dimensions, width and length, and rotated. The pictures are not identical, but they are similar. All that is needed is to rotate the second wombat and enlarge him to match the first wombat. In mathematics, similar figures have the same shape, ratios, and proportions, but not the same dimensions. If you can enlarge or shrink one shape and it will exactly match the other, the two shapes are similar. Even if you further need to flip or rotate a shape to make two shapes correspond, they are still similar. Now let's discuss proportions and ratios of similar figures. Similar figures reveal themselves mathematically when we study their dimensions. Take two right triangles, one with sides 4 meters and 6 meters long, and the other with sides 8 meters and 12 meters long. If we were to set up ratios of the two triangles' two sides, in which the short side is compared to the long side, we would see a pattern. Let's take the smaller triangle's short side, 4 meters, and set it in a ratio to the long side, 6 meters. Now repeat this for the larger triangle's short and long sides, either as a fraction or as a ratio. As you can see, the relationship between short and long sides is the same, 2/3, for both triangles. You can also compare ratios between the two figures. Take the two short sides and compare them to the two long sides, again either as a fraction or a ratio. The ratios of the triangles are the same. They are 1/2. We can even use the third side, the hypotenuse, to confirm this ratio. When we compare hypotenuses, we get the same relationship. All those relationships simplify to 1/2, which means that these two triangles are in proportion to each other, exactly 1/2 the size of the other, or 1/2 the size of the other. All polygons can have similar pairs: two triangles, two squares, two pentagons. You just cannot say a right triangle is similar to a square, for example. Not all similar figures are as easy as wombats or triangles. Take these two rhombuses, for example. Take any one side of the first rhombus and compare it to the other rhombus, so you get 4.5/3. No matter where you look, these two rhombuses have the same ratio of corresponding sides. You can do this for any two polygons. If you were given angle measurements, you can use them. Angles of similar figures must be congruent. Only the sides are in proportion to each other. The angles are always congruent. Here are two pentagons that should be familiar to anyone who rounds the bases. Are these two home plates similar? You can compare the ratios of any corresponding sides. 5.666 divided by 17, 2.833 divided by 8.5, and 4 divided by 12. All three ratios are the same, 1/3, so the two figures are similar. Not certain yet? Compare ratios between the figures. Let's use the diagonal and the top as a ratio: 12 divided by 17 and 4 divided by 5.666. If those two ratios are equal, then the figures are similar. They are approximately equal to each other, due to decimal rounding, which means the home plates are similar. Understanding how similar figures work and seeing relationships between similar figures can help you in both geometry and real-world applications. The most common way to use similar figures is ages old. Knowing the size of a small figure can help you estimate the size of a larger, unknown measurement. You notice your basketball-playing buddy is exactly 2 meters tall. On this particular sunny day, his shadow is 1 meter long. He is standing next to a eucalyptus tree, the type native to Australia, home of our wombats, that cast a shadow of 10 meters long. How tall is the eucalyptus tree? Think of this problem as two similar triangles. If the two triangles are proportional, they are similar. Here is how you set it up. 1 divided by 2 equals x divided by 10. Now, you solve for x, and you find that the eucalyptus tree is 20 meters in height.